Hello everyone, welcome to the second video. Well, I guess this will be the third one now. The other one was just a part 2. So in this video I will be covering the SLO number 6, 8, and 10. Number 6 is where I determine the component form of a vector. Number 8 will be will express a vector in terms of unit vector I and j. Number 10 is where I perform vector addition, subtraction, and scalar multiplication. Let's begin. Number 1. Vector initial point is negative 12, comma 7, and the terminal point is 2, comma negative 5. From here, when we do component form, we take the terminal point, we subtract it by the initial point, which then equals c minus a, comma d minus b, where a in this case equals negative 12, b is 7, c equals 2, and d equals negative 5. So from here, we do 2 minus 12, which in this case, these double negatives here will turn into a positive. And then we have negative 5 minus 7. So we have 14 from the first one, and from this one we have negative 12. So the vector form and component form will be 14 comma negative 12. To convert this to vector units I and j, it all comes from where I is equal to 1 comma 0 and j is equal to 0 comma 1. So if the component with the vector is in component form, which is a comma b, you will get, you just add the I to the A vector and add the B to the J vector, keeping the operation of vector B. So in this case, we have V equals 14I minus 12. Again, we kept this one here from this. So we're doing vector addition this time. This is V plus U. V will be 14 comma negative 12, which is what we got up here. And then we have U, which will be a given. So in this case, we have the component form. And then we're going to take the second one. Then we're going to be a plus c, comma d plus, well, b plus d, which in this case, like I said, v was the one that was given from up here, and then u is the one I'm giving you now. So from here we got 14 plus the 2, again a and c, negative 12 plus the 15 will be the d, well, the b plus the d. So v plus u will be 16, which is when you add 14 and 2. And then negative 12 plus 15 will give you 3. Second problem, we have the vector initial point, which is 4 comma 7, and the terminal point, which is 1 7. So finding the component form again, take the terminal point minus the initial point will give you c minus a comma d minus b, where a in this situation would be 4, b would be 17, c is 1, d is 7. So we have 1 minus 4, 7 minus 17, negative 3 minus negative 10. Well, that's what you get from subtracting them. In this case, you have negative 3 and comma negative 3. To convert this to vector unit I and vector unit j, you will have, well, this all comes from, again, from the previous slide, where we have 1 comma 0 for I, and then j is 0 comma 1. So if the vector's already in component form, you're going to add I to the vector A and j to vector B. So in this case, v equals negative 3 and minus 3. We kept, what's it called, the operation from vector B in this situation. So to subtract the vectors, you have v minus j, well, minus u, sorry, which v was given again with the negative 3, negative 3. In this case, if it's in component form, you will subtract it to the other, which is u, which is also got to be in component form. Which in this case will be a minus c, b minus d. So from here we have negative 3 minus negative 3. Oh. And then we have u, which is negative 5 minus 4, is the one that I'm giving you now. Negative 5, comma 4, sorry. Negative 3, again, you will see the double negatives here. Well, this becomes into a positive. So in this case, it would be negative 3 plus 5, negative 3 minus 4. So v minus u equals 2, comma, negative 7. Question 3. We have the vector initial point, which is negative 9, comma 2. The terminal point, which is 32, 1. To find a component form, we take the terminal side minus the initial side we've been doing previously. Where in this situation, a will equal negative 9, b will equal 2, and c will equal 32, and d will equal 1. From here, we have 32 minus 9. Again, we have this double negatives here, not to trip you up, but just to keep you reminded. Here we got 1 minus 2. So 32 plus 9, since we have the double negative, will be 41. 1 minus 2 will give you negative 1. From here, the vector is 41, negative 1 in component form. To convert this to vector I and j, we do what we did previously. If it's already in component form, we would just add the I to the j, and then we add the, well, we add we have the a, we will add I to the j, sorry, and then we add b to the j, if it's already in component form. So in this case, we have 41i minus j. Again, I didn't put the negative 1, since the negative 1 is implied. We kept the operation from b. So this is just negative or minus j, which is 1 minus negative j. But the 1, it's already implied, it's in front of the j, so we just put the j there. So for scalar multiplication, in this case, will be where you will distribute the k with the a and the b. So in this case, u will be 41, negative 1, it was given. So the k in this situation, I guess k is a variable, k could be anything, negative 3 u, so we take the u down, and then we will distribute negative 3 to the 1 and also the 41. In this case, you get negative 1, 2, 3 when you multiply negative 3 by 41, and then you get negative, well, you get the double negatives when you multiply negative by a negative, will give you positive, so you get 3. So now we're going to go over everything I just showed you in the previous slide, so everything in one quiz. So I will give you u, which is 4, 7, and I'll give you vector v, which is 3, 9. In this situation, we're going to be doing u plus v, as well as 2u plus v squared. Again, you'll be squaring the vectors, what's already in this component up here. So this will be the 1 squared. And then we have u minus 3v. And for the fourth, I decided to draw a little graph of how you will probably see the vector in your exam. Again, this will be the initial point, this would be the terminal point. So I'm going to give you the equations from previously. Well, for this one, you need to find the component form for number 4, as well as the vector unit I and j. I'm going to give you the equations that we were doing prior to this. So here are the equations that you will probably be needing to solve these. And I will pause well, I can't pause it. You will pause the video now and try to do the problems. Alright, now that you tried it yourself, let's go ahead and solve these problems. For 1, you will have 4 plus 3, and you have 7 plus 9, which will give you 11, 12. And that's for vector u plus v. For number 2, you will have 2u, which was again given, so 2 and the 4. Then you would distribute the 2 and the 4, and then you will square the here you would distribute the 2 each side here, and then you will square the 3 and square the 9, and then here you would again, when you square it, 2 times 4 gives you 8, 2 times 7 gives you 14, you square 3 gives you 9 and 81 when you square 9. Then adding these together, 8 plus the 9 will give me the 17, and then the 14 plus the 81 will give me 95, sorry. For the number 3, you have u minus 3v, which is 4, 7 minus 3. You would distribute the 3 here, which gives you the 9, and this gives you the 27. So 4 minus 9, 27. You will get negative 5. When you do 4 minus the 9, and then when you do the 7 and the 27, 7 minus 27 will give you the negative 20. So from here, we're going to do number 4, which is component form. So you take the terminal point minus the initial point. You got the double negatives here, so watch out. Everything will be converted back to normal. So 6 will be 6, 8 will be the answer here. Since it's already in component form, the only thing you have to do is add the j to a and b. And that's the end of the video. Thank you for watching.